go ahead and work. So some of these we're not going to go ahead and work together, and you'll see why probably next week. The only other thing I want to go ahead and remind you of, you have it right now, what's due on Monday. Okay, the homework for geometric sequences and series. So if you're having any trouble with that, come on in. I'll be here Monday morning unless circumstances are out of my control. Come on in, see if I can help you out. Okay, so this section is all about systems of equations and quadratics. So it looks like we're probably going to talk about systems today, maybe quadratics. We already did a little bit. But help me out here. When I say the word system or system of equations, like what pops into your mind? Substitution and elimination. Those are the two top contenders. Great strategies for solving systems. Now, graphically, what we're talking about here, okay, is you've got a pair of intersecting lines, and you're looking for that one point or the multiple points of intersection. And you might be thinking, well, how can two straight lines have multiple points? Well, if you don't remember, I'm going to go ahead and show you. But let's start, any two lines, if you were to graph them in a coordinate plane, they could intersect, right? So how many solutions would you have? Just the one point. Okay, so a lot of times it's probably just the one point of intersection that you're going to be after, especially when you go ahead and create, these word problems, a system based on that. So there's one solution. There's another way you can graph 2 points and they can interact in the plane. What's another one that I'm thinking of? It starts with a P. They could be, I'm sorry? Now, it's true, perpendicular is correct, but that's just a specific form of intersecting. What's the word I'm fishing for if they never touch? Parallel. They could be parallel to each other. Well, if the system's answer, your solution, is based on where these guys touch, what's my answer if they never touch? There's no solution. There is no ordered pair, X and Y, that's going to make both true at the same time. Okay? Does someone know? And then what's the last case? What's the final way that two lines can interact with each other if you graph them in the same plane? They're the exact same line. If you were to graph a line and then the other line turns out to be exactly the same, one right on top of the other. Okay, this is when you have how many solutions? An infinite number of solutions, yes. In fact, does anybody remember the term we have that describes this? Starts with a C. If both lines in the system are exactly the same. We say they coincide. They coincide. Also what you should do when it rains. Coincide. Still got it. Okay. But all right, how many ways are there to solve a system? There are a ton of ways to solve systems. I am going to be showing you, by hand. I'll also be showing you on the calculator. But as Spencer told us just a little while ago, substitution and elimination, those are the top contenders. Those are usually the top two that people go for. In fact, how many people in here prefer, if you're going to do it by hand, elimination? Substitution. How many people are not quite remembering what I'm talking about when I say elimination and substitution? Okay, that's fine. That's fine. Okay. So I want to go ahead and work B and C. Okay. Solve the following systems of linear equations using a graphing calculator. We don't need a calculator. Now I'll show you the calculator once we're done, but again, I like to show you things as hand by will. Well, I'm not going to stop here. Give the solution as an ordered pair. Okay, so I want the one or multiple ordered pairs that are going to make this true. Now, if you're going to use elimination, let's go ahead and start with that first. It's also called the addition method, because what you're doing is you're going to add the two equations together, hoping to get one of the variables to drop out. Okay, we say we eliminate that. Now, you want them in standard form if you're going to go ahead and do that. That means both of the variables on the same side and it equal to your constant. So 5a minus 11 equals 4b. I'm going to go ahead and rewrite this a little bit. I'm going to subtract the 4b over, and I'm going to add the 11 over. So I'm going to have 5a minus 4b is equal to 11. Okay, now we're going to review that again, at some point. That's what we call standard form. The ax plus by is equal to c. And does anybody happen to know, this is kind of off topic, because we never get off topic in here, right? Man. Anyways, does anybody happen to know what are the 3 restrictions for standard form? It's not considered standard form until you have these 3 conditions met. Libby?
Just kidding.
Okay.
I thought you were asking something else.
Oh, okay. Anyway, there's something about the leading coefficient. Has to be positive. Okay. The next one is usually a favorite for a lot of people. No fractions, no decimals. They all have to be whole numbers or integer values. Okay. And the third one, can anybody tell me? It has to do with A, B, and C. The values themselves. So the leading coefficient has to be positive. Typically, it's the value of coefficient of x. No fractions, no decimals. And A, B, and C cannot what? Well, now it's okay for some of them to equal 0, but not all of them. That's true. But I'm thinking in terms of their factors. What am I talking about when I say factor? Like, what's a factor of 9? 3, because 9 is divisible by 3, right? So they can have no common factors except 1. 1 is the only one they can have. Now, that's all 3. If 2 of them have a common factor besides 1, that's okay. It's just all 3. Okay. All right, so we got this one. What would the second equation be if I wrote it so that I had a, b, and then my constant? Okay, so 7a minus 8b is equal to a positive 1. Does anybody want me to just write the equation over to the side and actually show the addition and subtraction to how I got here, or is everybody okay with that? Nobody wants me to write it out? Okay. All right, well, we're going to go ahead and use elimination on this one. And here's the thing about systems, really any method you choose is going to solve the system, with some exceptions. Has anybody ever heard of Cramer's rule? Okay, that's a method of using matrices and what we call determinants. So again, I'm looking at the folks that I taught Algebra 2 to. You don't remember Cramer's rule? From Seinfeld? Actually, that is a fun fact. It was named because that gentleman did create it, so it was named Cramer's rule. No, actually, that's made up. But it sounds real, right? Okay. Man, this is a tough room today. Jeez. Okay. But let's go ahead and solve by elimination. So the idea is to add the 2 equations together, and hopefully one of your variables is going to drop out. So let's see. If I just go ahead and add them up right now, 5a plus 7a. 12a, negative 4b minus 8b, minus 12b is equal to 12. So neither of these drop out. If one drops out, then I'm left to solve for the remaining one. So this one isn't ready for elimination. So what I'm going to do is I'm going to manipulate it. You can multiply one or both of your equations by different values so that your coefficients on a chosen variable are opposites. And you can always choose. There's a lot of freedom in these. I can choose to have the A's drop out when I add them, or I can have the B's drop out when I add them. Okay? So sometimes, unless you're willing to go fractional, you might have to multiply 2 equations, each equation by some value. Okay? So let's start here. Graceland, what would you like to see cancel, A or B? A. So let's say I want to get rid of A. All right. Now, what I need is a common multiple for 7 and 5. Not a factor, not what divides them. What's the first number that they will evenly divide into together? 35, right? Okay. So in order to get this to be a 35a, I got to multiply it by 7. To get 7a to be a 35a, I've got to multiply this one by 5, right? But there's still a problem. Remember, we want this specific variable to what? We want it to cancel. Well, right now they're both positive. So again, one of them's got to be negative. And it doesn't matter. I put the negative on the 7. You can put it on the 5, as long as they're opposites. Okay. So let's go ahead and multiply through. So negative 7 times 5a negative 35a, plus what? 28b is equal to negative 77. Okay. Now let's distribute the 5 across the other equation. 35a minus what? 40b is equal to 5. Okay. Now add them up. The opposites are going to cancel just like we wanted. I'm looking for a 28b minus 40b. Negative 12b. Yep, that's what it'd be. Okay. And negative 77 plus 5. Negative 72. All right. And see, when you eliminate one, you're able to solve for the other immediately. So we divide through by negative 12. So my answer is going to be positive what? Six. There we go. There we go. All right. So it is 6. But now here's the thing. Are we done? Now remember, we're looking for the solution to the system, which is an ordered pair. So we only have half of that. Now, if it's x, y, you know the order in which we go. But if they use other variables like this, they're always going to be put in alphabetical order for your ordered pair. So what we really found here is just the second value. We know what B is, but I don't know what A is. So all I have to do is go back into one of the original equations, the first one or the second one, okay, does not matter, and just plug in my 6 and see what happens, okay? Carolina, which one do you like? First one. Okay, so 5a minus 4b. So 5a minus 4b, but instead of b, I'm going to put in the 6, is equal to 11. Okay, so I don't have to write this again. 4 times 6 is 24. If I add that over, 24 plus 11. 35, divide through, so A equals 7. Okay. This is elimination. Okay. Is that coming back to you? I wonder how long has it really been since you've seen a system? Has it been a while? Okay. No? Okay, good. Now, what if I chose to solve this system by substitution? Would I get the exact same answer? I would. If I solved it using matrices, would I get the same answer? By Cramer's rule. Yeah, the method does not matter. It's really just what you prefer. Okay. Now, here's what a lot of folks are probably waiting on. Now, how would I solve this if I were going to go ahead and plug it in the calculator? And here's what you do. Here's the nice thing about this. Plugging it in the calculator, you don't even have to have it in a specific form. Whatever equations you have, you can type those in directly. Now, the only thing is that we're going to have to plug in x and y. So let me show you what we have here. We're going to go on my scratch pad. We're going to go to menu. Does anybody know? Algebra. And then solve systems. Okay, right below where we put in an equation if we wanted it to solve. Okay, and just kind of foreshadowing, this is where we're going to be able to put in quadratics if you're wanting to solve those as well. Okay. Typically, I kind of go with graphing, and I'll tell you why when we get there. But the number of equations is 2. So if you do happen to have a 3x3 system, you're trying to solve for x, y, and z, you could make that a little larger. And see, this is programmed for x and y. So that's why we have to change it. So what was it? So 5a becomes 5x. What was the rest of it? Minus what equals 11?
5x minus 11 equals.
Oh, minus 11 equals, okay. And then 4b. Okay, so that would just be 4y. Okay. And then what was the other equation? 7x. What? Minus what? 1 equals 8y. Okay, so you just type it in exactly as you have. As soon as I push enter, oh, 7.6. Okay, good. So, I mean, it's good news if you come across a system on your paper exams. I still would recommend, if you have a little bit of time, show some work by hand instead of just showing that you did it on the calculator. Does that make sense? Okay, because the graders will like to see a little bit of work, and even if your answer is wrong, remember they can always give you points for that. Okay. All right. Let's try C. And let's solve this one by substitution. Okay, so what is substitution? There you go. Okay, so what you want to do is solve one equation for one of the variables, and then you're going to plug that expression into the other. And that's the key. Always, always plug it into the other equation. The biggest misconception I saw when I taught this in Algebra 2, people would accidentally plug that expression back into the original equation that you got that from. Okay. Now, this one here, it would still work on B, the one we just did, but it's better on a system where you have a variable with a coefficient of 1. Because like in the other one, if I were to solve for either of these, A or B, what would I have to do? Oh, not distribute. I'd have to divide out that coefficient, right? And that's going to give me fractions. But who knows? I mean, a lot of people out there are probably thinking, fractions, why don't we solve it that way? But it really depends, again, on what you want. So let's do this. This one, I wanted to use substitution because there isn't even an R in the second one. What is S? Okay, S is equal to 1. All I did was take the second equation and just go ahead and solve it, right? Okay. Now, I'll go back and I'll revisit this one, but can you see why I went ahead and did substitution on this one? Okay. All right. So let's see here. If I plug this back in here, I got 1 plus 3R is equal to 4. 3R equals what? 3, so R equals, say, 1. All right. So my ordered pair should be 1, 1. Okay. Now, let me go back and just kind of show you how we would do this with equation or a system. If you did want to go ahead and use substitution, but it didn't have a coefficient of 1, let's go ahead and say A or B. Sydney, what would you like me to solve for? Okay, solve for B in which equation? First or second? Second one. Okay. So let's say I have 7A minus 1 is equal to 8B. All right. The idea behind substitution, I'm going to solve one of the two equations for one of the variables. So this would be B equals 7/8 A minus an eighth. Oops. Backwards. Okay. Someone's having a really good time in math. I don't know what's going on. I'm kind of conflicted if I should walk over and see if things are okay, or you think I should?
Yes.
Hey, sorry to interrupt. I just heard like a moan or something. Is everything cool?
Yeah, yeah, we're good.
Okay.
No, I have
Y'all
a question.
reviewing or something? Or?
We're doing it.
Oh, okay. There you go. There you go. Okay. They're playing a Kahoot game. So I guess somebody was like, oh, whatever. Yeah. And the fun part is it was all recorded, so you can go listen to it later tonight if you want to. Anyways, where were we? Okay, so we solved the second equation for B. So now I have B in terms of A, so I'm going to go back and I'm going to plug that expression into the other equation, and that's the key. Always, always in the other equation. So instead of 5 times A, okay, oops, sorry, 5A minus 11 is equal to, instead of 4B, I'm going to have 4 times 7/8 A minus 1/8. And then see, you have one equation with just a one variable that you can go ahead and solve. Okay. And of course, you can do that by hand. Remember, we now have the numerical solve on the calculator that can help you out. But there we go. Questions?
So Is substitution.
That is substitution. When you take a portion of one equation and place it in the other. Yes. Okay. Does anybody want me to carry it through to the end to show that we're going to get the same answer? No? Okay, good. Good. All right, what else do we have here? I'm just going to say Mrs. P because I don't want to try and mispronounce that, is writing a test for her Algebra 2 classes. The test will have free response questions worth 2 points each and multiple choice questions worth 4 points each for a total of 100 points. She wants to have twice as many multiple choice problems as free response problems. Write a system of equations that represents the number of each type of question. Now, you've seen these before, these story problems, these word problems, for a very long time in your academic career. The first thing I always suggest is labeling your quantities. Okay, so Zoe, what variables would you like to use? X and Y. Okay, so what are my quantities here we're talking about? Okay. So we have free response and multiple choice. So how am I going to label these? Is it the types or is it the points that I'm labeling? It's the type. So let's say X is going to be the number of free response. I'm just going to go ahead and put FR for free response. So I don't have to write that out. So Y is going to be the number of multiple choice. Okay. Now let's go ahead. One equation is going to come and be based right on the number of points that each problem is going to be worth and the total number of points on the test. Okay, so can anybody tell me what that equation would be? 2 points for each free response and 4 points for a multiple choice question. Okay, so 2 points for every free response question plus 4 points for however many multiple choice questions we have on there should give me 100 points total. Okay. Now, wording on the other one, that can kind of throw some people around. She wants to have twice as many multiple choice problems as free response problems. So we're going to go ahead, here's how I like to do these. I'm going to go ahead and set them equal to each other, right? So X is the free response, Y is the multiple choice. She wants to have twice as many multiple choice problems as she does this. So whatever these numbers are, I want Y to be double this. Okay. So I could say 2x equals Y. What's another way I could do that? I could say X equals 1/2 Y. Okay. Would either be okay? Yeah, it just really depends on, what equation you want to use. Since we didn't do fractions on the last one, do we want to go with fractions? Yay! So X equals 1/2 Y. Okay. Now, again, you could solve this using any method you want, but this one here is geared more towards what? Elimination or substitution? Yeah, substitution. You'll notice one of your equations is already written in terms of the other. I already know that X is equal to 1/2 Y, so I'm going to go ahead and plug that into the other equation. Okay, so 2X becomes 2 times 1/2 Y plus 4Y is equal to 100. 2 times 1/2 Y. Okay, so 1Y, and I'll go ahead, Y plus 4Y. So 5Y is equal to 100, so Y is equal to 20. Okay. And now what? Let's see, Karime, what equation would you like to use to solve for X? Okay. And this is also another reason why, people prefer substitution. Will either equation work? Yes, but I would probably lean towards the equation that's already solved for the one I'm looking for. X is just 1/2 Y, so I know this would be 1/2 20, so that would be 10. So I know there's got to be 10 free response and 20 multiple choice questions. Okay. How we doing? Okay, how much of algebra is just kind of coming back to you right now? A lot? Making sense? The good old days? No? Okay. Oh, you said yep. Okay, I thought you said numbers then. All right. Okay. Well, let's see here. Moving on. What's the next problem I want to do? Okay. I want to go ahead and do 3C. Okay, so this one is using what's known as a matrix equation. We have matrix A. That's what's called my coefficient matrix. Coefficient matrix. Okay. B is called my constant matrix. In mathematics, we are not really creative when it comes to naming things. Why do you think we call that the coefficient matrix? Yeah, look at the system that this was created from. I literally just taken those coefficients right off of the two equations. See, 2, -1, 1, 2. Why is B called the constant matrix? It's just made of those constants what the equations equal. It's not listed here, but typically we do use X to represent this variable matrix. Okay, that's what we call it, just the variable matrix. Okay, well, what we're going to go ahead and do here, I'm not going to worry about showing you inverses or anything like that, but unless anybody wants me to, I don't think it's really necessary. What I'm going to go ahead and show you, if you're trying to solve a system and you have both of these matrices, the coefficient matrix and you have the constant matrix, if you plug it into the calculator and type this, A inverse B, that will immediately give you the variable matrix, which is your solutions. Okay, so what I could type in the calculator is going to be matrix A, 2, -1, 1, 2. Make sure it's an inverse. And then I'm going to multiply it by -7, -18. As soon as I do that, it's immediately going to go ahead and give me the answer. Now, I'm not going to show you this by hand. Does anybody remember how to multiply matrices by hand? Did anybody ever do that at one point? Did your teacher show you? Okay, good. All right, well, I'll tell you what. We're going to go ahead and stop there because I got 205. But just remind me that we started. I want to go ahead and do C. Okay. I want to go ahead and do C when we come in on Monday. All right. Let's go ahead and get those calculators up to the front.